so I'm going to get started. I'm going to share my screen. All right, so Clay, I'm sorry that the video didn't work yesterday, or earlier today, but it should work now. So we talked about perimeter area, circumference, volume, surface area, all of that. What we're going to talk about today is dilations involving those things. And we're going to walk through, before we get to like just the algorithm or the equation that you'll use, the formula that you use, we're gonna look at some things first. Okay, so consider this square has 2 centimeter sides. Remember that to find the perimeter, you add up all the sides, but if it's a square, you can just take the sides and multiply by 4 because they're all the same. So this perimeter is 8 centimeters. The area, remember, is length times width, so the area is 4 centimeters squared. Now, if we dilate the square by a scale factor of 2, meaning the square is going to actually, all 4 of the sides are going to be twice as big. Let's see what happens with the perimeter. So it's still a square, but instead of the sides being 2, they're 4 now. So we do 4 of those 4 centimeter sides means that the perimeter is now 16 centimeters. And the area is length times width, which turns out to be 16 centimeters squared. Now, we have a scale factor. The scale factor was 2. Let's see what happens between the perimeter and the area. So the scale factor of the perimeters. So let's take the bigger perimeter and divide by the smaller perimeter, see what the scale factor is, and it's 2, which is the same as the dilation scale factor. Now, you think that if the sides are going to be twice as big, that the area is also going to be twice as big because the perimeter was. But let's look at the areas. The area of the dilation was 16. The area of the original was 4. So that means the area of the dilation is 4 times bigger than the original area. Well, I can write 4 as the scale factor squared, 2 squared. Let's look what happens when we take that into 3 dimensions. Okay, so what we have up here on the right is a cube, and volume is length times width times height. So our volume here is 8 centimeters cubed. Well, if we dilate the cube by a scale factor of 2, meaning we're going to increase all the sides by 2, making them, instead of 2 centimeters each, they're going to be 4 centimeters each. So length times width times height is 64 centimeters cubed. So let's see how many times more the volume is. So we take the bigger volume and divide by the smaller volume, and we get 8. So even though we doubled the lengths of the sides, our volume is 8 times more when we double it. I can write 8 as 2 cubed, 2 times 2 times 2. That 2 right there is the scale factor of the dilation. Each side is twice as big. So what that means is, when dilating figures of scale factor K, the perimeter has the same scale factor. So the perimeter of the dilation is equal to the perimeter of the original times the scale factor K. And simplified, that looks like P sub D equals P sub O times K. The area of the dilation, remember on the square, whenever I dilated the square by 2, the area wasn't twice as big as the original area. It was 4 times as big as the original area. So the area of the dilation, you figure that out by taking the original area and multiplying it by the scale factor squared. So we could write it like this. Now I'm going to put a star, an asterisk up here, because this also works with talking about surface area, not just area of a square. So this works with three-dimensional areas also, surface area. And then volume, I'm going to scoot this down. The volume of the dilation is equal to the volume of the original multiplied by the scale factor cubed. So V sub D equals V sub O times K cubed. So let's see how this works. All right, so example number 1 says Levi wants to create a patio that is similar to his friend Cody's, but his yard isn't big enough. The diagram shows the dimensions of Cody's patio. Cody's patio is 20 feet by 30 feet. Levi's space is half the size of Cody's. How many feet of border material will Levi need, and how much area will he have to cover with gravel? So border material goes all the way around, so that represents perimeter. So even though Levi's space is going to be half the size, we've got to calculate how much border material, or his new perimeter, Levi's perimeter and Levi's area. Okay, border, it doesn't say perimeter in the word problem, but it says border, which, remember, border is perimeter. So is fencing, so is going around, okay? So Levi's is going to be half the size of Cody's. So the scale factor is going to be 0.5, because we're going to scale down Cody's patio to Levi's. So perimeter of the dilation equals the perimeter of the original times the scale factor. Levi's is the dilation. So we're looking for perimeter of the dilation. The original perimeter, if this side's 20, then this side's 20, that side's 30. So you add up all the sides, or you can do 2 times 30 plus 2 times 20. That's the perimeter of Cody's times the scale factor, which is 0.5. Let me rewrite that. So Cody's perimeter, 2 times 30 is 60, 2 times 20 is 40, 60 plus 40 is 100, times 0.5, which means if I scale down Cody's perimeter by half, Levi's perimeter is 50 feet. So Levi will need 50 feet of border material. He'll need half as much border material. Now, we assume that he'll also need half as much area. But let's see, okay? So the area of the dilation is the area of the original times the scale factor squared. So the area of the original is 30 times 20, length times width, and the scale factor is 0.5, but we're going to square it. 30 times 20 is 600. 0.5 squared is 0.25. So the area of the dilation, or Levi's area, is 150. So he will need 150 square feet of gravel. So if we think about it, it seems like he should need 300 square feet of gravel, because we're reducing the size by half. However, everything's being reduced by half. Half of the length times half of the width, which is 1/2 squared. Okay, number 2 says a circle with an area of 25 pi square inches is dilated so that its image is 10 pi square inches. What is the scale factor of the dilation? Okay, so we're looking at area, and all three of these things over here, perimeter, area, volume, also works for circumference for perimeter, because remember, perimeter and circumference are related, and then the area of circle, the volume of any circular 3D figure like a cone or a cylinder or a sphere. So we're talking about area. So the area of the dilation equals the area of the original times, since it's area, scale factor. So let's plug in everything we know. It says a circle with an area of 25 pi square inches is dilated so that its image is 10 pi. The image is the dilation. So the area of the image is 10 pi. The area of the original is 25 pi. And it asks us to figure out the scale factor. So we're trying to get k by itself. So the first thing I'm going to do is divide by 25 and pi. The pi's cancel on both sides. 10 over 25 reduces to 2/5. 2/5 is 0.4. Square root both sides. And my key is incorrect. So square root 0.4 is, so k is about 6.3. So the scale factor is about, 0.63, sorry, 0.63. Okay. Number 3 says it takes about 2 ounces of paint to cover all 6 sides of a rectangular box, which holds 15 cups of sugar. If the dimensions of the box are doubled, about how much paint would the new box need, and about how much sugar would the new box hold? So we got to decide. Cover equals area, and hold equals volume. Okay, so let's do the area first. Area of the dilation equals the area of the original times k squared. It's k squared because it's area. Let me let that truck pass. Okay, so the 6 represents the 6 sides of the box. So that 2 ounces is the original. It says if the dimensions are doubled. Okay, so the dimensions are doubled. That means our scale factor is 2. It wants us to find the area, or the surface area, of the new box, which is the dilation. The original amount is 2. The scale factor is 2, and it gets squared since it's area. That should be A sub D. 2 times 2 squared is 8. Holds is volume, so the volume of the dilation is equal to the volume of the original times K cubed. Since it's volume, that's why the K gets cubed. The easy way to remember that is the K gets cubed because it's centimeter cubed. The K gets squared because it's centimeters squared with area. Okay, so we're trying to figure out the volume of the new box, which is the dilation. The old box holds 15. The original box holds 15. The scale factor is 2, but it gets cubed. 2 cubed is 8. And 15 times 8 is 120. So the new box would need 8 ounces of paint, and would hold 120 cups of sugar. Okay, I'm going to go back. I'm going to stop sharing. I'm going to stop